Welcome back, students. In this video, we're going to cover Module 9, Lessons 1 and 2. Excuse me. So Module 9 is trigonometry. We're actually at First Coast going to do this a little earlier than the district. So we'll get started here. So, all right, we're going to start with a review question. All right, so how can we solve for the missing side of a right triangle? Here's your hint. So this is the Pythagorean Theorem. And it's a squared plus b squared equals c squared. So I'm going to do this one, let you guys do that, and then I'll do this one. I'm going to go ahead and write the word down here. So we're going to talk about Pythagorean triples, but the word is Pythagorean triple, singular. But right here. So, right triangle. I always like to draw the arrow to show this is the hypotenuse. So that's always the long side, wherever that box points you. And if you don't have the box, it's always the longest side. So this would be the hypotenuse over here. All right, but number one, they want x. X happens to be the hypotenuse, so it's going to be real simple. A squared plus b squared equals c squared. So it's 12 squared plus 35 squared is going to equal, I'll just replace it with x squared since we're squaring everything. So we got 144 plus 35 squared is 1225, and this is x squared. So we're going to move up here. All right, so x squared, we add these two guys together and we get 1369. All right, we'll change to the pencil here. It makes it easier. So we have x squared and we need x. So we're going to take the square. Sorry, pencil broke on me. So goodness gracious. So taking the square root of both. So x equals, and I'm just going to get in the habit, we're going to be using the calculator a lot in Module 9. So 1369, and this is the square root button. This is to square, this is to square root. So we want the square root, and square root of 1369 is 37. So x equals 37 for number one. Number two, so here we have c, we need this. So you're essentially going to say c squared minus a squared equals b squared. I'll set it up for you. You can solve it. All right, so you just need b squared, or just say x squared, because that's x. Okay. All right, over here, number three. Can a right triangle be made with side lengths 11, 12, and 13? I am happy that some of you guys in class had asked. They were like, well, you have to have, these two have to be bigger than the third. Well, that's for any triangle, but I appreciate you guys remembering that. That made me very proud. But what we need, so to make a right triangle, it's a squared plus b squared equals c squared. So we'll just call this a and b. Remember, 11 plus 12 is the same as 12 plus 11. 13 is the biggest one. That is your hypotenuse. So 11 squared plus 12 squared, it should equal 13 squared. So 11 squared is 121. 12 squared is 144. 13 squared, I believe, is 169, but let's just use our handy dandy calculator. 169 is that. Yeah, so 13 squared is 169. So, but let's just do this. So use the calculator. 11 squared, so 121, plus 12 squared, and that looks bigger than 169, and it is. So 264 does not equal 169. So will it make a right triangle? No, because a squared plus b squared does not equal c squared. So I had to fit that in. I apologize. Okay, moving on. Guided notes underneath. So Pythagorean Theorem. Pythagorean triple is a set of three non-zero numbers, whole numbers that we're going to call a, b, and c, such that a squared plus b squared equals c squared. The most common Pythagorean triples are shown below in the first row. The triples below them are found by multiplying each number in the triple by the same factor. So you're bold here. So 3, 4, 5. And just to show you, so here's 3 and here's 5. So I hope you see there's your X. But anyway, so that's a common. 5, 12, 13, 8, 5, 17, 7, 24, and 25. Now, these are kind of like multiplication tables. They're very good if you can memorize them. Not necessary, because if you use your calculator, it'll show you. And as long as a squared plus b squared equals c squared, then you have a right triangle. But just to show you, so if you multiply these numbers each by 2, so 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, or if we did 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. You see, you just add on. As long as it's 3, 4, 5, and you multiply it by any number, you know, a million, well, 3 million, 4 million, 5 million is the same as 3, 4, 5. So same here with these others, and it's times 2, times 3, times 2, times 3, and then it just shows that you can keep going on and on. All right, underneath. So if the sum is greater than the third side, so if you're a squared and b squared, so the longer these guys are, the smaller this angle becomes. So if a squared and b squared are greater than c squared, then you have an acute triangle. But if the hypotenuse is bigger, keeps getting bigger and bigger than these two guys, you have an obtuse triangle, because this is greater than 90 degrees. So greater than is acute, less than is obtuse, and we're going to put that to work below at the bottom. So I'm going to do number 1. You guys are going to do number 2. So you see, somebody asked me, well, how do you tell if you don't have a box? Well, 25 is bigger than 24 and 8, and 28 is bigger than these two. So these are your c squared. So we're going to see a squared, and I always just make the smallest a, but it doesn't matter. 19 plus 20 is the same as 20 plus 19. And I just put equals until I know better. So, calculator, let it do the work. 19 squared, so that's 361. Plus 20 squared, that's 400. Man, I ought to be a math teacher. So that equals, we're going to put, so this is 761. I shouldn't have put anything there. All right, now. So 28 squared, boy, that's 784. So 784 is greater than 761. That means that a squared and b squared is, so it's this. See, the c is greater than that. So this is acute. All right, so you're going to do the same with this. So a squared plus b squared, how does it compare? If it's greater than, if these two are greater than, then it's acute. If this is greater than, it's obtuse. And actually, I just wrote that wrong. This is greater than, this is greater than. Okay, all right, so see what you can do with that one. Flipping the page. All right, so top of the second page, and we have special right triangles. Now, there are 2 that we discuss in this class, and they're the 45, 45, 90, and the 30, 60, 90. These are both on the reference sheet, so you don't have to memorize this, but I want you to understand how to use it. People say, well, what is x? What is x square root 2? What is that mess? That sounds like some bad algebra stuff we haven't had to mess with this year. And that's true. That's why this is at the end, because it's a little bit more difficult, but it's not that bad. So when you have a 45, 45, 90, so this is the same as a right isosceles, because these two angles are congruent, these two sides are congruent. That's all this means, x and x. So if this was 5, this would be 5. Instead, if this was 3, this would be 3. Make sense? And whatever this is, so if this was 5, it would be 5 square root 2. If this was 3, it would be 3 square root 2. We're just going to leave it. We're going to say it was 2. And this was 2. So this would be 2 square root 2. So whatever was here goes multiplied by the square root of 2. Now sometimes it's going to tell you exact value. Let me just put over here. So when it says exact, that means radical form. And when it says nearest whatever, nearest tenth, usually that's going to be a decimal, so you will multiply, because the square root of 2 is like 1.4. So 2 square root 2, and while I'm here, so 2 times 2 square root, see, square root of 2 I said is 1.4 something. Then you have to hit equals. So these two guys would be 2. This one will be 2.83. So just a little longer. All right, over here, 30, 60, 90. Now this is with 30 at the top, 60 on the right. If you have it flipped, then you flip these. But the hypotenuse is always 2x. So down here at the bottom, where we have the 90 degree and the 60. So remember, if it's flipped, then this would be over here. But when it's 90, 60, that's x. The hypotenuse is double that side, so it's 2 times x. And then this third side is slightly bigger, so it's this times the square root of 3. Square root of 3 is like 1.7 something. So if this was 5, 5 times 2 would be 10. This would be 5 square root 3, which is, so if we said 5 square root 3, 5 times 3 square root, see, I said 1.7 something. It equals 8.66, we'll just say 8.7. So this was 5, this was 10, this was 8.7. So you get the idea. The number should make sense. In this case, this number should be bigger than this, but smaller than that. This should be double this. This should be the smallest number. Over here, these two numbers should be the same because they're both x, and this is x times the square root of 2. Again, that's 1.4 something, so it's going to be a little bit bigger than these guys. So let's put it into play. So over here, I'm going to do it. Over here, you're going to do it. Both of these are 45, 45, and because these are both x, that's how you know that. It's just like, see, these are x's, these are x's, so that's how you know it's 45, 45. So I'm going to do the ones on the left. You guys are going to do the ones on the right. We don't get to the 30, 60, 90 till the bottom. All right, so number 3. Find the values for y and z. Keep it in radical form. So either exact form or the exact number or radical form means the same thing. So remember, this is a 45, 45. So I know, see, this says z, and they're doing that because they know we're going to put x's in here and they don't want to confuse us. So these two are the same. So if this guy's 10, then y simply equals 10, right? Because they're the same. Whoops. Very simple. 10. Let me just do it like this. 10. All right, and z, so we know that this guy is x times the square root of 2 because of up here. X times the square root of 2. So if x is 10, all right, so z is going to be x square root 2, which is 10 times the square root of 2. Because this is x. X, we just put that number in there, plug it in. Hopefully that makes sense. Over here, remember these two guys are the same, so P should be easy. Q is this guy times the square root of 2. Easy peasy. Let me see you do it. If you have any questions, again, let me know. All right, so 45, 45, 90. They're calling this one x. That's good because this guy's x also. This guy's value is x square root 2. So if this number equals this times the square root of 2, we would divide it to get this one. So what you're going to have is 18 divided by the square root of 2. Because we just write it over here. So you know, if we have x times the square root of 2 and we're trying to get x by itself, we have to divide by the square root of 2. Well, in this case, it's built in. This is this. This, whatever this is, times this makes this. So that's why it's like that. Now, anytime you're trying to divide and get rid of a square root, you got to multiply by whatever it is over whatever it is. So in this case, square root of 2. So square root of 2, square root of 2. You're just multiplying it by 1. All right. Because this, anything over itself is 1. So 18 times the square root of 2 is 18 square root 2. The square root of 2 times the square root of 2, hopefully you guys know by now, it's 2. But just in case. So 2, we're hitting square root. So that's the square root of 2. And we're multiplying that by itself, or we're squaring it. So we get 2 back, right? I hope we follow that by now. All right, well, this reduces down. 2 goes into 2 one time. 2 goes into 18 9 times. So you end up with 9 times the square root of 2. And let me show you why that's right. So watch this. All right, so 9 times 2 square root equals times 2 square root equals, because that times this number included that. So if you multiply this by the square root of 2, so that 9 times the square root of 2 times the square root of 2, it's 9 times 2, which is 18. Somebody said, well, why can't you just divide it by 2? And put, so yeah, divide it by 2. Divide this by 2 and put square root 2 underneath it, because that's what all this did. It just gets rid of the fraction. So you guys here, so this one's easy. It's x, this is x, this is x, this is x square root of 2. Pull that x off of that x, that square root 2, and you have your answer. If you have questions, please let me know. Bottom of the page, number 7 on the left. Sorry for the shaking. We got some turbulence in the airplane. Just to see if you guys are paying attention. Throw some extra credit at you. I'm going to do Kermit the Frog here just for a moment. We're going to see this question. And if you heard that and aren't just taking notes, if you send me a message saying you heard Kermit or tell me in class, I'll give you extra credit. So, anyway, 30, 60, 90. So we learned up above. So when it's 90, 60 at the bottom, that's x. 90, 30 on this side is x times square root of 3. And that the hypotenuse in this case is 2x. So they want us to find y and z. Excuse me. So if this is x and this is 2x, z equals 2 times x, or 7, which is 14. So let's just call that 14. So we got 7 down here, 14 here. This is x times the square root of 3. Now they want it to the nearest tenth. So y is going to equal x times the square root of 3. And we're going to use our calculator, and we're going to say 7 times 3 square root equals 12.12. Now they say nearest tenth, so we don't round up. That would be 12.1. Now, because I already know in the next lesson I'm going to be writing down what to hit on the calculator, I'm going to go ahead and start here. I should have started this in class, but it's okay. So if you're trying to get this, so in the calculator you're going to type 7 times 3, and then the button that looks like this, that's the square root button. Then you have to hit equals. Sorry, my watch has decided to start listening to me like I'm talking to it. I don't know. And you end up with 12.12 nearest tenth. That's 0. That's the tenth, that first spot. All right, over here, I'll help you out just so. Remember the bottom, or the 90, 60 is x. Over here is your x square, x times square root 3, and this is 2x. Should be easy for you, I hope. All right, flipping over. Apologize, I didn't staple it, so I got to make sure. Yeah. And this will be the end of this lesson. This is lessons 1 and 2 of Intro to Trig. All right, so we're going to apply this knowledge of special right triangles. So, first thing, the perimeter of a square is 16. What's the length of its diagonal? So let's draw a square. So a square has 4 equal sides. It also has 4 90-degree angles. So the perimeter for a square is 4 times the side. Well, if we know the perimeter is 16 and 4 sides, we can divide both sides by 4, and we'll know that each side is 4. Hopefully, we know that 4 times 4 is 16, and we're already ahead of this. Well, now they're asking about the diagonal. Now, the diagonal cuts the 2 angles in half. So we're going to draw this bigger down here. So the outside of that square looks like this. And it's 4 here, and it's 4 here. The diagonal, so half of 90, because it cut these 2 in half, is 45. Well, notice these are congruent. These are x and x. So our diagonal is going to be x times the square root of, sorry, got to look back. I usually have it memorized, but x square root 2. Yeah, I keep wanting to put 3 there, but it's 3 for the 90, 30, 60, 90. So we have our x. So our diagonal, I'll just put diagonal equals x times the square root of 2. And in case, you know, I'm trying to look. Let me look back at the notes. What did we do in class? Oh, yeah, we did both. So, calculator, this is going to be 4 times 2 square root button equals. So, 4 times 2 square root button equals. So, 5.65, we're going to round up to 5.7. They didn't give us any sort of, you know, inches, feet, whatever, so we're just kind of stuck. Give me 1 second, you guys. I gotta. All right, so down here, I'm gonna at least help you set this up. Equilateral triangle. The perimeter is 3 times x. So plug in 36 times 3x. X gives you each side. The altitude cuts this in half, so you're ending up with a, because this is 60, 60, and 60, now you have a 30, 60, 90. So this is your x. This is x square root 3, and this is 2x. Remember, 2x, this is actually the side, so don't get these x's confused. This is, let's just say, we'll call it y. 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 So now, y is the same as 2x, so you're going to have to divide it in half to get this, and then whatever this is times the square root of 3 is the altitude. So hopefully I set that up. You guys, if you have any questions, let me know. The bottom, I'm going to kind of do the same. So this is 2 right triangles. What you have is on one side, this is 30. So that makes this 60. And then the other one is a, because you see this is 45, this is going to be 45. So they give us 34. They call this Z, which is the same as this. They call this X, and then they call both of these together Y. Now, 30, 60, 90 make blah. Don't get this confused, but so this is X. This is X square root 2. These are the same, X and X, but this is 2X, and I know, that's a different X. Bear with me. All I'm saying is these are the same. These three are the same. This is going to be twice what this is, and this is going to be half what that is. So z is 34 divided by 2, because this is 2x, this is x. So half of 34 is 17. So z, we'll just put it down here, z equals 17. So, so this is 17, this is 17. Actually, this is x square root 2. This is x square root 3. This is what messed me up. Yeah. So y ends up being x, not this x, I know, but whatever z was, times square root 3. So it's 17 times square root of 3 plus, over here it's just 17. So use your calculator. 17 times 3 square root equals plus 17. It's 46.44. I may have told you guys wrong. We did backtrack, but if you didn't, if you have something different, or you're checking your notes, that's why it's different. But so in the calculator, so it'll be 17 times 3 square root button equals plus 17 equals, and that's how you get that right there. Oops. Just a second. My wife texted me. I'm in here. 1 second. Sorry, guys. Okay. Actually, I think this is the end of the video anyway. Let me just make sure. Yeah, that next page is for lesson 3. So yeah, sorry to hold you here at the end. I didn't mean to do that. If you guys have any questions, please let me know. Until next time, have a good night.